switching gears to something else. The line of question is 5 types of chemical reactions in 10 minutes. Okay? There are a couple types that are pretty straightforward. A combines with B to make C. That type is called combination. No one is surprised by that name. We're combining things. If things fall apart, if the center cannot hold, if C splits apart into A and B, that is called decomposition, which again is a fairly normal name for that process. Decomposing, falling apart. There was a great comic when I was a kid called The Far Side that appeared in the Washington Post every day. One day they rejected the comic as potentially too offensive because it was a picture of some servants outside a room saying shh, don't make any noise. Instead of the maestro is composing at the piano, the maestro is decomposing. They thought that having the dead body was too scary or something to have in the Washington Post. Shh, he's decomposing. Also in the Washington Post when I was a kid was big news when Brad and Jennifer Aniston were married, and then these two people were in a movie together, and they end up becoming an item, and she got kicked to the curb, and chemists call that type of reaction a single replacement. Okay. You have some compound, actually, I'm going to do something. Instead of A and B, I'm going to do this compound as J and B, and along comes chemical A, okay, and then when it's over, we have a compound AB, and poor J is out there on her own. Single replacement. Many of us have been there in our own romantic lives. Liam, did you hear that we're in chemistry class and we're talking about chemistry? What is the other possibility? If this is single replacement, somebody tell me the next level of the game. Double replacement. Somebody tell me what they think a double replacement reaction is going to look like. We can start with J. Let's start with A and B and C and D. We'll get it out of the headlines. Somebody tell me what the possible products of a double replacement reaction here are going to be. Not quite. Because when I write chemical compounds, what type of chemical do I write first in both compounds? The metal. Generally, we write sodium chloride, so it's the metal that comes first. And metals tend to get what kind of charges? Positive. So instead of being AC plus BD, what is this actually going to produce? AD plus CB, because that's going to stay first. That's a minor detail. That's a smarty thing to know. Skip a line or two and write down, you don't have to write down these words, write down the chemical formulas that those would make. If I had copper 2 sulfate and iron, and as a matter of fact, I have those chemicals right back here, write down these chemicals. Do your best, talk to the person next to you. Copper 2 sulfate and iron. If I were to write the formula for this stuff, it's going to be CuSO4, because that has a +2 and a -2, and they cancel each other out, and then iron. If you look at these reactants, which one of the 4 types of chemical reactions we've learned so far do you think is likely to go down here? Single replacement is correct. What do you think is going to replace what? The iron is going to replace what part of that compound? The copper, correct. Why? They're both metals. They both tend to get positive charges. So, therefore, this should make FeSO4 and Cu. Here is a nail. This nail is made of iron. Okay, this is a fairly, like, touch it, nail. No, hold it. Okay, normal nail. It's a piece of metal. Okay. I'm now going to put it in this copper sulfate solution. Okay, we are going to let this single replacement reaction happen. I'm going to turn all the way around, and now I'm going to take this out of there. And you can see, I'll leave it a little longer. Well, you can see it started to happen already. You can see that this started to what looks like rust, but that isn't actually rust that happened on there that fast. That's copper metal. I extracted copper metal out of this solution. Okay, we did simulation. So if you look at the tip of this thing, you can see that's now like reddish. That's copper. Why do we dig it? Because we have to dig it to make this stuff. There's no like wells of this solution coming out of the ground. We can make it into solution and then we can pull it back out. I'll just pull this out. That's copper metal we got from this solution that quick. There was copper in the liquid. Ta-da! I have made copper appear in surfaces. The last type of chemical reaction is combustion. What does combustion, what does fire need to work? Oxygen is one of the ingredients in combustion. What else do you need for a fire? You need some sort of fuel, which is going to be some sort of hydrocarbon. CXHY is all I'm going to say right now. Right. And then I'm going to make a combustion reaction back here.
What?
Alright, let that go for a sec. What is one of the products of fire? CO2. When your car burns, when a factory burns, almost inevitably it produces CO2. What chemical is missing from the product side there? H. Is it going to produce hydrogen gas as the other product of a fire? No. Because what is hydrogen gas itself?
Yes.
It's a flammable gas. That's not going to come out of fire. Instead, that hydrogen is going to be bonded to something. What could it be bonded to?
The X.
The oxygen. The X just represents some unknown subscript name.
Water.
It's going to make water? What? That's not how it goes in Avatar. Okay? Fire doesn't make water. Okay? But let's look. Okay? Let's look back here at our fire. Okay? And where we have the fire hitting this had cold ice in it. And so where that works right around here, maybe they will testify that there's some condensation here. Maybe a little moisture. Again, these are very quick demos. I'm going to go for a little while longer. If you put a big pot to cook spaghetti on the stove, and you turn on first, it's full of cold water, you will see a rind of condensation appear on the side of the pot. That is water coming out of fire. Alright, I gotta let you guys go. Oh, I just saw a drop there. You gotta believe me, I lost my drop. Okay, I'm gonna give you guys the opportunity to practice this in the comfort of your own home. No, you don't have to thank me.
Too hard.
What I know.
Too hard. You don't have to think hard.
We didn't even get to do the fun thing at the end. Here.